Good morning, good morning, good morning. It's time for the next day of revenge with NTA because NTA took revenge on us in the January attempt by setting a really good paper, which is actually commendable considering the fact that easy papers make us dull, and you always need a good kind of questions, good conceptual questions to actually uh, you know uh, move yourselves ahead and to actually think out of the box, which is what you need in today's world. So why not take it up as a challenge? And let's get going to the next lecture of modern physics. Yep, modern physics. That's what we're going to do today. The concepts as well as the questions. And you will see the latest trending JEE Mains 2025 PYQs as well in this particular session, apart from some other questions. So all of this with none other than your Captain Shreyas. Smash that like button right now if you have not yet marked the attendance, and if you are still in that zone that okay, I keep watching videos, I know YouTube will recommend me always, don't be under that false notion. Make sure you are subscribed because you never know, you will start missing out those recommendations. So quickly subscribe and smash that like button so that you do not miss any classes. Thank you so much, guys. And in today's class we are going to do wave particle duality, de Broglie wavelength, atomic model, atomic spectra, nucleus, binding energy, the not the radioactivity law, just the radioactive reaction, p-n junction, logic gates, of course, and photoelectric effect. All these things in today's lecture. Good morning, Ayanshu, Miles, Maruti Ram, Pravi, Nikhil, Single, Ayanshu, Sukruti. Good morning, Miles Moral, Praveen, Lakshita, Jarvis. Nice to see you, Afzal. Hi, Agatyan. Good morning, Phil. Yes, the lectures have started. Maximum around 2 hours, not more than that. Okay. So I hope you guys are ready. JK, Vanakam, Vanakam. Yes, your Thala is here. Endariki Namaskaram. Namaskara. Good morning, everyone. Let's begin with the class. And I really hope that one day you will be one of these toppers. In fact, this year, I want Vedantu JEE English students to be over here. Some of the students over here obviously are our students only who then went on to the JEE crash courses or the Ekalavya batch, or our pro courses, and then they went on to become the toppers. I really hope that this year too you to make your name onto the leaderboard, and you are one of those 2000 selections who get into JEE Advanced. Yes, this is almost 1700 JEE Advanced selections who went on to become IITians. This year that number is going to be way higher, and I hope it breaches 2000 mark. All thanks to you. And I want every single student to take it up, not just for the JEE Mains. Yes, you should take it up for the JEE Advanced too, because JEE Mains is not the end, JEE Advances, and there are so many other exams, BitSat, UGEE, and so many more. I want everyone to crack every single thing, but the first step obviously is JEE Mains second attempt. So let's begin. In the concept of wave particle duality, what are the different formulas that you need to remember? Let me just talk about it. See, if you talk about light, light has two kinds of behavior. One is a wave behavior, the other is a particle behavior. The wave is nothing but electromagnetic in nature. The particle is basically called as photon. Similarly, our matter, which is electrons, protons, neutrons, all these things which make up everything around us, maybe the chair, the cloth, your skin, everything, the wall, everything is made of matter. Yes, it is again made of two parts. One is the wave part and the other is the particle part. The particle part has mass, yes, and the wave part is called as the matter wave. Is called as the matter wave. It is not electromagnetic, gravitational, or anything else. It is a different kind of wave. Like sound wave is different from C wave. So it's two different kind of waves, right? And in case of light, the mass of that particle is zero, but it has momentum which is given by h by lambda. Please never ever use never ever use mass into velocity, because remember, the velocity of that particle of photon is actually the speed of light, which is 3 into 10 to the power 8 meters per second. If you go over here, the particle's mass can be anything. It can be anything. Um, it can be anything. It can be anything, right? But the momentum is definitely given by mass into velocity. Momentum is definitely given by mass into velocity. Even the velocity can be anything. It need not be the speed of light. It can travel at low speed, zero speed, anything. So it can be literally anything. So that is one very important difference which you should know about. Then the next important thing, Then the next important thing, guys, the next important thing over here is the energy of that, wave-wise, you will see the speed of light is the frequency into the wavelength, and the energy of that particular photon, energy of that particular photon is given by energy of that particular photon is given by hc divided by lambda, where h is your Planck's constant, Planck constant. Never ever write this as this is never equal to half mv square. It is not kinetic energy. It is just the energy. It is the total energy of the photon. It includes everything together. Never can you write for light half mv square. But over here, definitely you can write, by the way, yes, the energy of that particular particle is in the form of kinetic energy, and definitely you can write it as half mv square, which is also the square of the momentum divided by 2m, Yes. Now talking about the wavelengths, how are they related to the momentum? That is very important. Here you will notice that this particular wavelength is related to the speed of light with frequency. Also, the wavelength is related to the momentum in case of light. But in case of matter, the matter wave, the matter wave has the wavelength given by h by p. Same formula. If you take lambda on the top, you can take p below. This is nothing but h by m times of v. This is called as your de Broglie wavelength. This is called as your de Broglie wavelength. This is very, very important when you talk about matter, particles, protons, electrons, neutrons, etc. Is the difference absolutely clear? Yep. Everybody with me? Understood till this point? The difference, is it clear? Absolutely. Give me a thumbs up, guys. Yep. Great. Now, also you need to remember, sometimes, say for a specific example of an electron accelerated by delta V volts potential difference, the de Broglie wavelength, which is h by p, which is h by mv, which is h by, or I can also write this as, by the way, root of 2 times mass times the kinetic energy, because momentum square is 2m square, 2mk. So I can also write momentum is root of 2mk. This kinetic energy can be also written down as the charge into the voltage difference by which it has been accelerated. But for a specifically for an electron, this h value, m value, q value, if you substitute, then you will get it as 1.227 by root of that particular voltage difference. This answer will be in nanometers. This is only for an electron. Only for an electron. This is in general. You can use it for a proton, neutron, alpha particle, anything, beta particle, anything. Because here mass, charge, everything has not been substituted. If you substitute the charge as 1.6, 10 to the power minus 19, mass of the electron 9.1 into 10 to the power minus 31, h if you substitute it as 6.626 into 10 to the power minus 34, all these values if you substitute, you will get this number 1.227 in nanometers. That is what the wavelength of the de Broglie wavelength will be of a electron accelerated by some voltage difference. Is this okay? No problem, Gauri. Just join in. We just started. Can you increase the volume? Oh my God, why is the volume less? Just hold on. I will use a different mic. Ha ha ha. Just see if the volume is fine now. Is the volume fine now? Just let me know. Is the volume better? Everybody give me a thumbs up. Smash that like button. Yeah, let me see the likes increase, guys. If the volume is fine. Yeah, if you're not at like, then please like. If you like, don't like it again. Okay, cool. So this is the main theory over here. How you compare the wave particle duality. Okay, the volume is good. Perfect. Let's go to the questions now. Okay, here is the first question on your screen. If lambda and k are the de Broglie wavelength and kinetic energy respectively of a particle with constant mass, then the correct graph, mass is constant, mind it is clearly mentioned. The correct graph representing the particle will be, so k and lambda, in fact everywhere there is 1 by k, so be careful. Is lambda related to the kinetic energy? Yes, it is. Remember, it was h by p. Momentum can be written down as root of 2 mk. That is what lambda is. But I want k, so square both sides. So lambda square is some constants, is some basically constants, because mass 2, h, everything is constant, and k will be there over here. So essentially, if you notice, lambda square into k is nothing but a constant, but I want 1 by k over here. That is the most important thing. I can also say lambda square is equal to constant times of 1 by k. 1 by k. So lambda square is constant times of 1 by k. So basically square of the lambda is proportional to 1 by k. So if the graph was lambda square versus 1 by k, it should be a straight line. If the graph was square of lambda versus 1 by k. But everywhere there is 1 by k here and lambda here. So think of it like this. 1 by k will be nothing but some new constant. 1 by k will be, take that constant here. It will become some new constant multiplied by lambda square. So obviously there has to be some curvature which is involved. There is some curvature which is involved. So guys, this is your y-axis. This is, think of it like your x square. So if you draw it versus x, it will be a curved line, and obviously when lambda is 0, or lambda is 0, 1 by k will be 0. So the graph should start from 0. It can't be a straight line because this is lambda. This can't be the answer because when lambda is 0, 1 by k is not 0. And what about this and this? As 1 by k increases, lambda also will keep on increasing. Lambda will also keep on increasing, and it will keep on increasing rapidly. It will not slow down its growth. So definitely answer D should be the correct answer. Answer D should be the correct answer. Very good. Everybody got it. Excellent, my dear students. Perfecto. Awesomeness. Awesomeness. Yep. It is like a parabola. It is a quadratic equation. You can think of it like that. So it has to be a parabola. Yeah. Next one, there is some proton has same energy that as of a photon of wavelength lambda. If the proton is moving at some non-relativistic speed, which means what? Non-relativistic speed, the speed is much lesser than the speed of light, because when the speed approaches the speed of light, then the relativity effects take into play and come into place, because of which the mass might change, and you have to use Einstein's equation to calculate the expanded or the new mass. So we are ignoring those effects. That's what it means. Then the ratio of the de Broglie wavelength of the wavelength to that of the wavelength of the photon is how much? So proton has the same energy as that of a photon. So if you first, let's talk about the photon of wavelength lambda. So the energy of that particular photon will be hc by lambda. So this is lambda of photon. I'll call it lambda 1. So lambda 1 will be hc by E. hc by E. So leave that aside. Now let's talk about the proton of certain mass. The de Broglie wavelength. The de Broglie wavelength. So this is de Broglie wavelength of your proton. This is the de Broglie wavelength of your proton is h by p, which is also h by root of 2 times mass times kinetic energy. They are the same energy, so that is also going to be that same E over here. So this is lambda 2, this is lambda 1. Obviously, we have to divide both of them because that's what they have asked. What is the ratio of both of them? So they have essentially asked what is the ratio. So therefore, lambda 1 by your lambda 2 will be equal to, first take this HC divided by E, and then later on take this number which is H divided by root of 2 times M times of E over here. So what is it that you are going to get? Check this out. Well, E and E will definitely cancel over here. E and E will definitely cancel over here. Root of it basically. So root E will stay below. H will cancel out completely. So C will stay on the top and I will be left with H cancelled. 2M is there. E and E root of it has cancelled. So only root E will stay below. So 2M. So 2M by root E should be there and C will be there. That is lambda 1 by lambda 2. That is lambda 1 by lambda 2. So they have asked the de Broglie wavelength to the wavelength of the photon. So that means they have asked lambda 2 by lambda 1. So lambda 2 by lambda 1, C will come below, C will come below, E will go on the top and this 2M will stay there below. So I think it is option D. Yes, option D. This is de Broglie wavelength and this is the wavelength of the photon. So they have asked lambda 2 by lambda 1, which is D option. Is that okay? Great. Awesome. Awesome. Sir, atoms is also going to be there. Yes, atomic structure after this. Atomic structure is going to be there after this. Okay. Okay. Concentrate, guys, on the class because I'm telling you, like before in January attempt, like in the CBSE exam, like it happened last year in 24, 23, 22, 21, 20. This, all these years we have been on this channel. Every single year, whatever we have been doing, whatever we have been teaching is not just asked, but even the similar models are asked. In fact, so many questions, so many times, students are so happy that they were a part of this channel. So be very serious about these questions. Just practice them. It will boost your confidence and it will also help you think in your assignments, homeworks, DPPs, modules, PYQs, which you are solving after the class, which you have to do, by the way. You cannot be completely saying that I will be only doing and watching these lectures, I'll be doing only the online lectures. No, you have to do self-study. Very important. If anybody tells you, just watch my class, you will pass, they are fooling with you. Remember that. Which of the following phenomena cannot be explained by the wave theory of light? Which of the following cannot be explained by the wave theory? Wave theory, guys, come on. Wave theory. Yes, refraction. Obviously, Huygens principle, wave theory can explain the refraction. There is a proof for that. Reflection also, Huygens principle, which is wave theory, can be explained by that. Diffraction is a perfect wave phenomena. Crompton effect is the odd man out here, which is a particle effect. Yes, the Crompton effect. Yes. So Crompton effect, which is basically the scattering of those photons by electrons. Yes, that is your Crompton effect. Everything else can be explained by wave theory. Yes, it is a D answer. Moving on, the energy momentum of a particle, of a body moving with, okay, is related by some equation. Given that C represents the speed of light, identify the correct equation. Now, this equation, when it came, many people got confused. Which formula is this? Because I just know E is equal to mc square. But sir, this formula is not there only in the book. Guess what? This is not even a question of modern physics so much. You know what? You know what is this question on? Actually, it is a mixed question of modern physics with units and dimensions. Yes. Usually, we know that energy is equal to mc square. I can see everywhere E square is there. So therefore, E square will be m square c raised to 4. M square c raised to 4 should be there. If it is m square c square, obviously this is wrong. M square c square is wrong. Dimensionally, E square should be same as m square c raised to 4. So either option A or option C. Got it? Everybody with me? Understood how we did it? Okay. But how to choose between that? Similar dimensions will be always added. You cannot add two physical quantities of different dimensions. Oh, okay. So how is momentum related to the energy? Is it related somehow? I think so. Well, the energy, which is kinetic energy is nothing but, I can say momentum square by 2m, but I can see speed of light in there. So I have to do something with that. I will write this as half mv square. Kinetic energy is half mv square. I want the speed somehow. So I will write it as half, energy is half m into v. So this will be nothing but half PV. So energy is half PV. So dimensionally speaking, the dimension of energy is the dimension of momentum into dimension of velocity, which is the same as the dimension of speed of light. So dimension of speed of light. So if I take E square, so dimensionally it should be P square C square. P square C square dimensionally. PC square is obviously wrong. P square C square seems correct. So who is there? C for Captain Shreyas. Yes, that's my handle, by the way, on Telegram, Instagram, if you want to get in touch with me. Great. This came in your shift. Understood, Hari, how to do this properly? Very simple approach. I eliminated two options. Whenever you don't have time, at least eliminate. If you're not able to think, take a guess between A and C. Always, always try to eliminate at least two options. Do not, I'm warning you, do not guess when you have eliminated only one option. That means three options are still remaining, because the probability is very low of getting correct answers, because there is -1 mark. Please remember that. Okay, it's better to guess with a risk when you have eliminated two options and only two are remaining. That's okay still. I wouldn't suggest it though, but this is like, your last chance, or you have no other option, or you have completely raised your hands. That's when you do it, not initially. If there is an electron and accelerated from rest through some voltage difference, the de Broglie wavelength is this many nanometers. The voltage is how much? I want every single person to spam the answer in the chat box right away, right now. Yeah. 11 topics coming up next week. I am going with the order. I don't know how many of you seen this particular video which I made. Where did it go? Where did it go? This video. I made this video. I don't know if you have seen this properly. Here I have given one proper list of the topics which were asked the most in the January attempt. You can see this. Yep, you can see this. Ray optics, modern physics. So I'm going, taking up those kind of topics initially. I'm taking this purple zone because at least that will give you 50 marks to 60 marks. Yeah, it will give you 50, 60 marks in physics alone, I'm saying. So then we can go to 70 marks, then we can go to 100 marks. So that is the order I'm following. I hope this is okay. Cool. All right. So what is the answer? Everybody's saying D, somebody's saying A. Come on, guys, decide on the answer. D for IIT Delhi. Okay. Sure. Well, what is the formula? 1.227 upon root delta V nanometers. Lambda is 1.227. That number should ring a bell in your head. This is nanometers is equal to 1.227 nanometers. This is the root of delta V. 1.227 just cancels. So this will become 10 to the power -2 is equal to 1 by root delta V. Square both sides. This will become 10 to the power -4 is 1 by delta V. So therefore delta V will become 1 by 10 to the power -4, which is 10 to the power plus 4 volts, of course. So 10 to the power 4 volts is the D option. That is correct. IIT Delhi. Very good. I hope your dream comes true. Oh, D for Diksha ma'am. Oh, Diksha ma'am fan spotted. Thank you, guys. Okay. Let's go to the next. Okay, I don't know why this came over here. Okay. Yeah. Photoelectric effect. Photoelectric effect is where you see light following on a metallic surface and then ejecting out electrons, because the photons of light are carriers or packets of energy, and they utilize their energy and knock out the electrons from the metallic surface, often the cathode, and there is some energy which is required to knock out those electrons, where minimum energy without which the electrons won't leave their place or leave their atom. That energy is called phi, which is the work function, the minimum energy required to knock out the electron from that atom, from that metallic surface. Hf is the energy associated with that photon of that frequency nu or f, you can say. And when these electrons are knocked out, they will have some kinetic energy remaining. Obviously, that will be the difference of those energies which were incident versus what is required to take out. So if I give 100 joules of energy, 20 joules was required to pluck it out. The remaining 80 joules will be present as the kinetic energy of those electrons. So that is your Einstein's photoelectric equation. This maximum kinetic energy can also be measured as E times of V naught or E times of Vs. This Vs stands for the stopping potential, meaning if these electrons fall onto the other metallic surface, they will start to conduct and there will be a current which will be set up in the circuit. Now, if you want to stop that current, you put a battery over here to oppose that flow of current. So when that current becomes zero, you have stopped that flow of electrons or the current. That voltage which you apply across the plates is called as the stopping potential. So you are absorbing all the kinetic energy against the work done by the electric force. So that is why the kinetic energy is the charge multiplied by that voltage which you have applied. So that is the stopping potential. If you plot the graph of the voltage that you apply over here versus the current that you get, you will see the graph will be like this, and there is a cutoff of the current when you reach the stopping voltage. You can see the stopping voltage is on the negative side. This is the positive side. There are two sides over here, negative and positive, because when you apply the voltage opposite to the general flow of the charges, then what happens is the current becomes less and less. You're opposing it, so that's why you will see the current reducing, eventually becoming zero at the stopping voltage. But when you apply positive voltage, you are helping the flow of the charges. You are helping the flow of the charges. So the current will increase. So the current will increase. That's why you will see the current increasing. But then comes a limit to that increase, because if there were 100 photons falling on it, only 100 electrons can come out of it. Even if you put external voltage, more electrons can't go between them, because each photon contributes to maximum 1 electron, and that's it. So if you have reached that saturation, current won't increase even after taking help from this battery. So that's the reason why it will saturate after some time, unless you decide to put more intensity of light. Instead of 100 photons, you put 200 photons are incident on that metallic surface. Obviously, 200 electrons can get knocked out. That means the current flowing in this circuit will be more. So that is the reason why the graph goes up when you increase the intensity of the light. But remember one thing, intensity of the light has nothing to do with the stopping potential. Even if I use 200, 300, 400 photons instead of 100 photons, yes, more photons will fall, more electrons will come, but still the energy of every photon is just dependent on its frequency. So the maximum kinetic energy that the electron can have is limited by the work function and the frequency, and is independent of that intensity, So that's why all the graphs terminate over here. And you will also see how this particular graph is also very important when you draw the graph of potential versus the frequency. 1 by lambda is like frequency. Those graphs are always straight lines with the same slope. Slope is nothing but h by e. Very, very important. The slope is nothing but h by e. This is just like frequency. Very important graphs. Okay. Shall we do some questions, guys? Yeah. How to remember the formula? How to remember the formula? Just remember what is happening. Whatever light is falling, it is using the energy to remove the electron, and the remaining is as kinetic energy. So the energy of the photon is hf or hc by lambda. Work function hf naught, threshold frequency this is, or you can also use hc by lambda naught, this is threshold wavelength. Maximum energy is nothing but charge multiplied by the voltage, which is the stopping voltage. So this is how you can remember this equation very simply. It is a energy equation. Energy incident is utilized and this is what is left out. Is that okay? Great. Moving on to some questions now. If you take an experiment with photoelectric effect, the stopping potential will be, yeah, come on guys. If you take an experiment with photoelectric effect, the stopping potential will be 1 by E times the maximum energy, increases with the intensity, decreases with the intensity, increases with the wavelength of the incident light. Very straightforward. So I just told you that the stopping potential is exactly, it's independent of the intensity. So it has got nothing to do with the intensity of that incident light. So B and C directly eliminated. There is no relationship only. I just showed you over here. Stopping voltage has no relationship with intensity, irrespective of that stopping voltage is same. In fact, it depends on some other things. What is that other thing? Well, we know that the stopping voltage into E is nothing but the kinetic energy. So stopping voltage is 1 by E times of kinetic energy, which is obviously option A. Does it increase with the wavelength? Let's think about it. Well, if you have photon of wavelength lambda, this is the work function. This is nothing but what is it? The stopping voltage. Okay. So if I increase the wavelength, this whole ratio, this whole number will reduce because denominator has increased. So stopping voltage should also reduce. So it says that it increases. This is definitely wrong. It should actually decrease. It should actually decrease, not increase. So hence D option is also wrong. Yep. A for whatever. A for April attempt. Oh my God, who is that? Hitman, correct. A for April attempt. Very true. A for April Fools. Guys, I hope we just don't become fools this time. Yeah, really. Matlab, means I don't want any student to be left out taking a drop this year. I want every student to get a good college, if not IIT, NIT at least, if not NIT, at least a good government college. Okay, fine. Even if you want to go to some good private college, but even if you are paying some fees, but it should be a good private college like BITS. Yeah, at that level. So I really hope you make it through this time because enough is enough. Let's give it our finest shot and let's hang out with the coolest crowds from the coolest schools, colleges of the country. Let's take part in the freshers party. I mean, just imagine, picture yourself, guys. You are in the freshers party. You are in the departmental college gatherings of the finest, most polished, most refined, the elite crowd of the country in one of the best colleges, hanging out, making friends, yeah, doing all those college activities. That will be one of the best things that you can imagine for. I don't want you to spend the next 4 years regretting, oh, my friend went to IIT, oh, my friend went to NIT, oh, my friend went to that, and I'm sitting here. I don't want you to feel that. So please put in your 100%. So you should get VIT, BITS, whatever, triple IT, NIT, IIT, SRM, all top colleges I want you to get, guys. Okay. So let's put in our 100%. Let that be your motivation. Given below are two statements. One is labeled assertion, other labeled reason. Emission of electrons in a photoelectric effect can be suppressed by applying large negative electron potential to the photosensitive material, and negative electric potential which stops the emission of electrons from the surface of a photosensitive substance varies linearly with the frequency of the incident radiation. Okay, what do you think about this? Okay, I have moved. Okay. Yes, I know you cannot see it. What do you think about it? Yes. What is the correct answer for this? Well, emission of photoelectrons of photoelectric effect can be suppressed by applying sufficiently negative electron potential. So if these are the plates, we know that those electrons which come out, they can be stopped over here by applying the stopping voltage. So you can stop those electrons and make the current zero. So is assertion correct? Definitely it is correct. There is nothing wrong with that. What about the next one? Negative electric potential which stops the emission of the electrons from the surface of a photosynthetic sensors varies with the linearly. Oh, this is this graph. Stopping voltage versus frequency. I just told you that the graph is a straight line, correct? So stopping voltage versus frequency is a linear graph, definitely. But how is this explaining this? Just because the word stopping potential is used does not mean it is explaining it. It's like saying sky is blue, blue is my favorite color. So that is why, I'm explaining why is the sky blue. Somebody asks you why is the sky blue and you are saying blue is my favorite color. Blue is favorite color? True. Sky is blue? Yes. So is my reason correct? Why is it explaining? How is it explaining why is the sky blue? No. So they're just two things, but they're not explaining each other. So it is not the correct explanation, guys. B option. Very good. Some of you got confused and said A, but I hope now you got it correct. Yeah, very good, very good. Great. Let's move. Let's move to the next question. The ratio of the power of a light source to that of a light source is 2. Power ratio is 2. S1 is emitting this many at this much wavelength. S2 is emitting this much wavelength. How many photons is emitted by it? Question on power and number of photons and the wavelength. Okay, let's have a look. Yes. Okay. So more negative at the photosensitive surface means the current will increase. No, you're just applying negative to the expected. So that's what you are applying. Negative voltage means you are opposing it. That's what they meant. Don't take it so literally. Okay. Who was that? Sashwin. Yeah. Now, yeah, in this particular problem, power is nothing but this is power. P is power, not momentum. Total energy, total energy upon the time taken to emit that energy. Total energy is the number of photons multiplied by the energy of each photon. Let's say the time be taken as T. Now, N by T, I will keep it separate. Energy of a photon is hc by lambda, and this is nothing but power. Great, I think I found it. What I can do now is power 1 to the power 2, P1 by P2 is nothing but N by T of 1 upon number of photons per unit time of 2. Hc is a constant, so it is inversely proportional to lambda. So lambda 1 here, lambda 2 here. That's it. So this is the relationship. Power is proportional to N by T and it is inversely proportional to lambda. And the ratio of the power of 1 to 2 is 2. So this is basically 2. For the first guy, these many photons were emitted. So 2 into 10 to the power 15 photons were emitted. For the second guy, exactly we have to find out. Second wavelength is 300. The first wavelength is 600. Both are in nanometers, so the units cancel. Don't bother about it. So 2 cancel. So 1 is equal to 10 to the power 15 by N by T of the second guy multiplied by this is 1 by 2. Obviously, N by T of that second guy, 1 by 2 is 0.5 into 10 to the power 15. So this is 0.5 into 10 to the power 15, which I can write it as 5 into 10 to the power 14. 5 into 10 to the power 14. So the correct answer over here should be 5. Just check this out. Yes, it is 5. What a simple question. But you should know how to play with the power, energy, number of photons and time and take the ratio eventually. Right? Let's go to the next question, guys. Coming up. Okay. Yeah, Bohr's model. Bohr's model. Let's go through it. Now, before Bohr's model, just read the theory of NCERT, Thomson's model, just read through it. Okay, Thomson's model, Dalton's model, just know the theory. You should just know, sometimes it might come in match the following. Okay, pie pudding model, okay, or watermelon model is Thomson, scattering experiment, Rutherford, okay, and how that scattering experiment showed that the nucleus is concentrated. Just have an idea about it. That is good enough. And Bohr's model, just know the postulates and their final results. Need not know the derivations. Derivations game is over because this is not your CBSE board. Yeah. So you should know not this one. The radius is proportional to n square by z and into a naught. This a naught is basically around 5.3 angstroms. So n is your principal quantum number. N is 1 means K shell, n is 2, the second orbit, and so on and so forth. Z is your atomic number. Like for hydrogen, it's 1, helium, it's 2. Basically, the number of protons inside the nucleus, which decides your chemical property. So radius is square proportional to n and inversely proportional to z. Then obviously you also need to know velocity. Velocity is directly proportional to z by n. This also you should know. This is the velocity of the electron in any orbit. Velocity of electron in any particular orbit. Yes, please know this. This is one thing. This is the second thing which you should know. I'm blocking only those things which you should know, guys. Okay. Then you should also know that the total energy is the sum of kinetic energy plus potential energy, and the total energy is given by this particular formula. Additionally, we can also add one more term over here. Let me add it actually. Yes, it is z square by n square. Yes, z square by n square and into 13.6 electron volt with a negative sign. So this is the energy of an electron, total energy of an electron in an orbit. Z is atomic number, n is your principal quantum number, minus 13.6. So the first orbit, the ground state will have negative 13.6. The second shell, the L shell will have minus 3.4. The next shell will have minus 1.8 and the next shell will have minus 0.8. Just remember these four values. That's good enough. 13.6, 13.6, then 34, that is 3.4, then 15, that is 1.5, and then 85, which becomes 0.85. Just remember these numbers. Many times you might need it as a direct value, which will help you in the calculation. Or else you have to put n is 2, 3, 4, and then find out what are these numbers sometimes. So it's better to remember these values. 13.6, 3.4, 1.5, and 0.85. Okay? Everybody with me? Clear? Yes. As you go higher and higher, finally, you will reach the last shell, n tends to infinity. That is where the energy is zero and that electron is basically free when n tends to infinity. When n tends to infinity. Next, you should know about excitation energy versus your binding energy, or basically, ionization energy. Excitation energy means if I want to take the electron from the first state to the second state, that is your first excited state. This one will be your second excited state. This will be your third excited state. So excitation energy is how much energy I will require to go from the ground state to the excited state. So if I, let's say, go from here to the second excited state, at second excited state the energy is 1.5. Here it is minus 13.6. This is minus 1.5. If you take the difference, that will give you the excitation energy. That will give you the excitation energy. Clear, guys? So wherever you are in the excited state, take that energy minus the ground state energy. If you take the difference of these two, you will get the, yes, excitation energy. If the question is on ionization energy, then remember always the final state will be infinity. Ionize means the electron has gone off. It will now become a cation. Yes, it will become positively charged atom. So the electron is let go. So the energy difference from the infinity, which is 0, minus 13.6, which will just make it 13.6 electron volt for hydrogen. For helium, lithium, etc., it will be obviously different. It will obviously be different. Yeah, keep this in mind. Another important thing which you should know is that the kinetic energy formula is directly calculated. Forget this. You can directly calculate from here only. it is nothing but the negative of the total energy, and the potential energy, sorry, this is 2 times of that, my bad. No, 2 times of kinetic energy. Yes, 2 times of basically the kinetic energy will give me the total energy, and potential energy is just uh sorry guys, my bad. I made a mistake here. Kinetic energy is just the negative of kinetic total energy, and the potential energy is nothing but two times is nothing but 2 times of the total energy. Yeah. Yes. Kinetic energy is the negative of the total energy, and the potential energy is double of that. Potential energy is nothing but the double of that, your total energy, which is there. So if somebody asks you what is the kinetic energy of the electron in the ground state, then you will say, yes, it was negative 13.6. So make it positive. So just remove that negative sign. It will become plus 13.6. So plus 13.6 electron volt is the kinetic energy of that particular electron. If somebody asks you what is the potential energy of this particular electron in the ground state, you will just make this double. Yes, you will just make it double, minus 13.6 into 2. So that will just make it, yeah, 27.2. That's all. I hope this is absolutely clear. All these formulas, this energy levels, and also remember the gap is more here. It becomes less, less, less. It is not equal gaps. From 1 to 2, 2 to 3, 3 to 4, it's not the same energy. The jump, which is from 1 to 2, is the highest energy. Then 2 to 3 is little less and less and less and less as you make the next and next jumps. Keep that in mind. Is that okay, everyone? Right. So the frequency of revolution of electron in the Bohr's orbit varies with n, the principal quantum number n, as how does it change with n, the principal quantum number? Come on, my dear students. What do you think is the correct answer for this? Frequency of revolution. Frequency, guys. Frequency is nothing but 1 by time period. Okay. Time period is nothing but the circumference by the speed. Okay. Speed is v. Okay. Circumference is 2 pi r. Wait a minute. This is 2 pi. I'll just keep it as it is. Now, velocity, I just told you that it is proportional to z by n, isn't it? I just told you it is proportional to z by n. So it will be some constant into z divided by n. What about radius? It is some constant into n square by z. I just told you both these things right over here. V is proportional to z by n and radius is proportional to n square by z. Okay, so constant, z's and so many other things are there. So what will this become? 1 by 2 pi is there. This z will go on the top. It will become z square. C1 by C2 will be there. Yeah. And what is happening with n, guys? N is there below. N into n square will become n cube. So how is the frequency related to n? Frequency is inversely related to n cube. So I think 1 by n raised to 3 should be the answer. Yes, 1 by n raised to 3. Got it? Yes, very good. C for captain. Very good, Gauri. Praveen, Nivikavi. Awesome. It's Ayush. Nams, Jayantika. Cool. Very good, Adam. Yeah. I'll come to the Lyman-Balmer series also. That is atomic spectra. Very good, Jarvis. Gaming Joshan. Awesome. Awesome, guys. Proud of all of you. Proud of all of you. Okay. Great. Huh. Moving to the next question. See this. The de Broglie wavelength of an electron in the second Bohr orbit. De Broglie wavelength in the second Bohr orbit, where r is the radius of the first Bohr orbit. This is a killer question. This uses a concept. I'll tell you this particular concept also because this can be used at times. See, other questions are simple. Find the energy, find the kinetic energy, find the speed ratios, find the radius ratio. Yeah, those are standard questions which directly involve how is it proportional in any of these cases. Those are direct. But how about this? This uses a concept. which is as follows. If you take any orbit, any orbit, guys. Oops. If you take any orbit, okay, this is your nucleus, this is the electron which is there in that particular orbit. The electrons de Broglie wavelength, yes, the electrons de Broglie wavelength. So this particular one wave is the de Broglie wavelength. This is your de Broglie wavelength, which will be h by mass of the electron into velocity of the electron. Guess what? If you put all these wavelengths one after the other in that particular orbit, exactly n number of exactly n number of wavelengths will fit in, where n represents the principal quantum number of that orbit. So if this is the nth, if this is the nth orbit, if this is the nth orbit, then what happens is n times of the de Broglie wavelength will become the circumference, guys. This is very, very important. Keep this rule in your head, in your notes, everywhere. Very, very important. N is the principal quantum number into de Broglie wavelength of the electron in that orbit. That is the circumference. Is that okay? So now what will happen, guys? Now what will happen? Yep. So think about it. Which orbit are we in? Second orbit. So this is 2. I want the de Broglie wavelength over there. So the de Broglie wavelength of the second Bohr orbit is how much? Circumference is nothing but 2 pi radius in that second orbit. Okay. Now I can do one thing. What is the radius in the second orbit? We all know radius is proportional to n square. So R2 by the ground state, when you're in the second orbit, n is basically 2. When you're in the ground state, first Bohr orbit, n is 1. So square this. So from this, I will get R2 is R naught into 4. R naught into 4. So I can put, instead of R2, R naught multiplied by 4 over here. So this will be 2 times of lambda d. This will be 2 times of lambda d. 2 will cancel. So what will lambda d be equal to? 4 pi r naught. This will be equal to 4 pi r naught. Yes, 4 pi r naught. No, not 2 pi r naught. Why will it become 2 pi r naught? It is square. Do not forget to square it. If you forget to square it, then you will get the option as B. Got it? Yes, this will be useful for VIT also. Hari, obviously, 100%. Please watch the JEE classes. Don't say VIT sir, start new series for VIT theory. Theory is same. Problems are different. We will conduct VIT series. By the way, we are conducting VIT specific strategies, PYQs and discussion sessions in our JEE crash course. Yes, check out the combo JEE package which is there. The description box has that link. Check it out. When you open the JEE main second attempt crash course in English, there will be 3 options over there. Check out the second or the third option. Yeah, the first option is pure JEE crash. The second option and the third option are with VIT examination. So definitely please check it out. Okay. So answer is 4 pi r naught. Next, let's go to, yeah, C for NIT Calicut. Great. Yep. Okay, let's go to the hydrogen spectra, atomic spectra in general. So every particular atom has a unique signature, like you can sign it. So when you have many atoms, they will collide with each other, and because of that, the electrons get excited when they exchange energies, and these electrons get excited to a higher energy state. And once they get de-excited, okay, it's like giving ice cream to a kid or giving a chocolate to a kid. The kid will be very excited. Hey, hoo, ha, hoo, ha, hoo, it will dance. Okay. And then finally, when the energy is gone, finally comes back to the ground state. I'm like, okay, I want to sleep. So it will get de-excited. And in that process, when that process happens, there is a photon which will be emitted. Yeah, you can also excite the atom's electrons by making light falling onto it, So when photons fall, then those electrons will jump to the higher orbit. So that is also possible. That is also another way of exciting it. Now there are two kinds of spectrum. One is called as the absorption spectrum, second is called as the emission spectrum. What is the meaning of absorption spectrum? You make a, a huge range of wavelengths fall on a particular element. Let's say white color, white light, or many colors are falling onto it. All the wavelengths are there. 1 nanometer is there, 100 nanometer is there, 1000 nanometer is there. Now when all these lights will fall on an element, all the electrons of these atoms, they will start taking those energies of those photons falling on them. Some electron will take one particular energy and jump to second orbit. Some electron will jump to third orbit. Some will jump to fifth orbit. Some will jump to fourth orbit. Some will jump to ninth orbit. So whatever energy is required for the jump, it will be like, okay, I need 2 joules. 2 joules. Where is that photon of 2 joules? Oh, come here. It will jump. Oh, I want 5 electron volt. 5 electron volt. Okay, that 5 electron volt falls on it, it will jump onto the higher orbit and it will get excited. So you will see out of that particular spectrum of light, certain wavelengths intensity will go down because they get absorbed by those electrons in getting excited. So that is called as absorption spectrum. You will see some missing wavelengths in that particular thing. The exact opposite is called emission spectrum, where those electrons are already excited and now they start cooling off, they get de-excited. In that process, they will start emitting multiple colors, as in photons of different wavelengths, and those wavelengths are very unique to their jumps. If it jumps from here to here, this wavelength. If it jumps from there to here, this wavelength. So those jumps are unique to their energy signatures. That's why you will get a lot of photons which are emitted, and if you mark them on a scale, you will get the emission spectrum. That is what it is. Whether it is absorption or whether it is emission spectrum, this formula is constant. R is Rydberg's constant, 1 by n square minus 1 by m square, where n and m are the two principal quantum numbers of those states from where the excitation or de-excitation is happening. From 2 to 5, 5 to 7, whatever. So it can be some things. If you ever get confused, what should I put here versus here? Make sure that this number is big, this number is small, because then the number will be positive. So if this has to be big, this has to be small, and this has to be big, because always big number minus small number will be positive. When it is in the denominator, this will be small number minus the big number. Okay, you can also write it for other elements as well. You just have to multiply z square over here. Yes, you have to just multiply z square over here. Then you can write it for other elements like helium, lithium, etc. So this is the generic formula of the wavelength 1 by lambda. 1 by lambda is z square r, 1 by n square minus m square. Cool? Okay. So you should also know from what to what is what spectrum basically. So just remember this. Yeah. Lyman, then you have Balmer, then you have Bastian. So Bastian, bracket, fee fund and all that. So Lyman is when the jumps are happening from higher energy states to basically n is equal to 1. Balmer is when the jumps of de-excitation are happening from higher energy states to n is equal to 2. Bastian is when the jumps are happening from again higher energy states to basically n is equal to 3. You also have p fund, bracket and all of that. That is for n is equal to 4, n is equal to 5. I have put it in specific colors because why? Lyman series, the colors are usually in which range? What is it? Is it X-ray? Is it infrared? Is it microwave? Is it ultraviolet? What is it? Lyman series usually. Come on, guys. Yeah, that R was the radius of the first orbit. Kirti, please check the channel name. What is the name of the channel? You guys don't check the channel name and watching the video. The name of the channel is Vedantu JEE English. 100 channels are there for Hindi. We were the first ones to think that students from South India, Northeast, abroad, many cities, many schools, they learn purely in English. And yeah, it is an international language. When you go to MNCs, everything, you cannot talk in local language. Understand that. We are helping you and you are talking, why are you not talking in Hindi? Yeah, ultraviolet, correct. Balmer, white means what? Visible spectrum. And then Passion onwards, it is infrared and infrared only. Yeah. Got it, everyone? That's how you can remember it. Okay. Who is the longest and who is the shortest wavelength? How to decide that? How to decide that? This is the logic. Remember this. This is the logic, guys. The energy difference is hc by lambda. So if you want lambda to be maximum, then the energy difference should be minimum. Energy difference should be minimum. If you want the lambda to be minimum, then the energy difference should be maximum because they are inversely related. So if there is a small energy gap, the wavelength will be large. If it is a big energy gap, the wavelength will be small. That's how you are going to remember it. Yeah, correct. Yeah. Moving on to the next question on your screen. The number of spectral lines emitted by hydrogen atom that is in the fourth energy level. Come on, guys. This is very simple. Everybody should be able to get it. Little bit of mathematics. Little bit of mathematics involved. The number of spectral lines involved which is in the fourth energy level. This is 1, this is 2, this is 3, this is 4. This is n is equal to 4. Come on, guys. So if that electron is there, what all can it do? It can go from here to here. It can go from here to here. And then the number of spectral lines that you will get emitted by atomic hydrogen that is in the fourth energy level. Then it can go from here to here, and then it can go from here to here. Or it can directly jump from here to here and then jump from here to here. Or anything else which is remaining? Yes, maybe it jumped from here to here, and instead of jumping down here, maybe it jumped down directly over here. Maybe it jumped down directly over here. So that is also a possibility. Instead of just jumping here to here, it jumped down directly over here. All these are the possibilities. Just count it. 1, 2, 3, 4, 5, 6. So guys, number 6. Number 6. Correct. Yep. Very, very good. Yep. Beef. B for who is this? I don't know who is that. Oh, yeah. B for IIT Bombay. Come on. What are you guys saying? B for IIT Bombay. Yeah. Great. So usually what you should do is whenever you get such questions, don't sit and count in the exam. 1, 2, 3, 4. No, no, no. Just use this concept. You have 4 lines and you have to choose two lines as a combination. NC2, choice of 2 among 4 things to choose from. NC2. Yes, n into n minus 1 divided by 2. That is what you can use in general. Moving on. Okay, what is it? Next question. If you take an electron going from A to C, the wavelength is 2000 and it becomes 6000 if it jumps from B to C. Then the wavelength of the energy of the transition from A to B is how much? Okay, so there are 3 energy levels as far as I can see. Okay, if the electron goes from A to C directly, so this is A, this is B, this is C. If it goes from A to C, if it goes from A to C, then it is 2000 Armstrong. If it goes from B to C, if it goes from B to C, then it is how much? 6000 Armstrong. The question is if it goes from A to B, if it goes from A to B, then how many Armstrongs will it be? Okay, here is what we can do. Observe this carefully. This energy gap and this energy gap, if I add them, I will get the total energy gap. So energy difference between AC will be energy difference between A to B minus, plus energy difference between B and C. Energy difference between B and C. Is that right, everyone? Everybody with me? Clear? Okay. So what now, sir? This energy gap is the energy of the photon. Is that energy of that photon which will be emitted, and the energy of the photon is always hc by lambda. Here also hc by lambda. Here also hc by lambda. So that lambda is what this is. So for A to C, it is basically 2000. Everything in Armstrongs. For A to B, I have to find out. For B to C, it is nothing but 6000 Armstrong. Here, this wavelength, I do not know. Yes, this particular wavelength, I am assuming it as lambda. Got it, my dear students? I'm just adding this energy gap is this gap plus this difference. That's all. So Hc cancels. Even Armstrong will cancel. So I'm just left with 1 by 2000 minus 1 by 6000 is equal to 1 by lambda. Armstrong, everything is in Armstrong. So 1 by lambda is nothing but 2000, 6000, the LCM is 6000, and this will become 3 times, so minus 1. So this will become 2 by 6000, which is 1 by 3000. So this is 1 by lambda. So this means lambda will be 3000. So lambda will be 3000 Armstrongs, which is D option, direct. So got it, guys, how to do it? Yep, D option. Jamil, if you got 85.6 percentile, there is a huge scope of improvement in the last 2-3 weeks. And yes, this is a series only meant for you guys to bounce back into the April attempt, because first clearing the high weightage topics very important, because lot of students think I will do those other things later on. That no, first focus on high weightage, get bare minimum 50-60 marks around that figure, then do the medium weightage, and then go to the high weightage or those difficult ones. So if you are getting even half the marks, that's 150. So 150 marks means close enough to 95-96 percentile, around that range. And if you start doing the medium weightage also simultaneously, you are a part of the crash, or you are solving tests, or you are practicing questions, it will push you to 190-180 marks. That will be close enough to 99 percentile. Got it? Okay, let's move to the next thing. Nuclear binding energy related questions were asked a lot. So let me just tell you some more things of nucleus over here. All the important formulas, guys. So remember, atomic mass number. This is atomic mass number. Atomic mass number is Z, which is the number of protons, which is also called atomic number, not mass number, plus n, which is the number of neutrons. This particular A is also called the number of nucleons. Nucleon means protons and neutrons together. So all the nuclear particles are called as neutrons. Keep that in mind. Okay. So whenever things have the same number of protons but different neutrons, so whenever Z is going to be the same, whenever Z for two elements is going to be the same, they are called as isotopes. Whenever number of neutrons are going to be the same, they are called as isotones. And whenever atomic mass number is going to be the same, they are just called as isobars. Okay. Next important thing, when you have that nucleus, obviously you will have some protons also, neutrons also, something like this. And these are your protons, green ones. Okay. And it will obviously have some volume, it will obviously have some radius and all of that. So my dear students, the radius r is nothing but a constant into the atomic mass number raised to 1/3. And if by chance you try to find the density of the nucleus, density of that density of that nucleus, rho, that will be always a constant for all the nucleus. It is independent of A. Yeah, that is another important thing which you should be knowing. All these particles stay together because of something called as the nuclear force. Nuclear force is a force between proton, proton, neutron, 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 proton, and it is not dependent on the charge. It is not dependent on the mass. It is the strongest force in nature. It is a very short distance force. It depends on the spin of the neutrons and the protons. And that is a force which is helping bind the nuclear particles together. Else, the protons would have repelled and flown out of the nucleus. When the nuclear particles are assembled together, then the energy is getting released. That energy which is released in the formation of that nucleus by calling all the protons and neutrons together inside that nucleus, it involves the loss, the destruction of the mass. That mass which is lost or destroyed is called as the mass defect. That is called as the mass defect. So delta M is nothing but nothing but your mass defect, and c is obviously the speed of light. So 3 into 10 to the power 8 meters per second, which is the speed of light. This is the binding energy. This is the binding energy. Yes, this is called as the binding energy. And if you divide the binding energy by the number of nuclear particles, which is the number of nucleons, what you get is this quantity called as the binding energy per nucleon. Binding energy per nucleon. This particular quantity gives me the stability of that nucleus. Per nuclear particle, how much energy is released? It's like when you release gas, you become relieved. Ha. Same way, guys, when nuclear particles assemble together and they release energy, they become relieved. They're like, oh, now I'm feeling better. It happens, right? When you eat a lot of food and you release gas, then you're like, oh, now I'm feeling better. My stomach is good. So same way, more the energy released per nuclear particle, more stable it is. And if you draw that graph goes up like this and goes like that. And the reason for that is when you reach higher atomic numbers, more nuclear particles, as in the neutrons are there. These neutrons are like binders. They are like holding their friendship together, and that's why they become more stable. But when too many people crowd at a place, then it becomes a hodgepodge. So then the stability goes off. It's like if you are single, you have nobody to talk to, you are very unstable. You're like, oh, I just have one friend or two friends. Okay, better. I have five friends. Okay, I have one big group, sir, full. If I go to one restaurant, sir, I go with 20 people. 20 people we hang out, sir. We go to the beach, sir, we hang out with 20 people. Sir, if we go on the bike, I go with 20, 30 people. Very happy. So iron is the happiest nuclear particle of all, because it has the highest binding energy. But when you have too many friends, imagine you have 500 friends, you'll be like, oh my god, I don't even know them. First of all, how are they my friends? Even 500 friends, how is it possible? It becomes full mess. So the stability begins to reduce. That's what happens. And that's why at a very high stage it becomes radioactive in nature. It will disintegrate. So if these elements go to achieve stability by breaking down, that is called as fission. And if these elements, they think, oh, let's make more friends and become like iron, they will combine together. So combining is called as fusion. So fusion reactions go like this, fission reactions go like this to achieve more stability. Is that okay? Yeah. Awesome. Awesome. Nikhil, which part you want? Please let me know quickly. Yeah. Yep. Cool. Shall we go ahead? Yes. Uh, yeah. Remember this. Sometimes you might be also asked Q value. So don't get scared. Q value is also just like this. The Q value of nuclear fusion or nuclear fission reaction is just how much is the mass difference multiplied by c square. Often, if this mass defect is expressed in AMU, if it is expressed in AMU, then c square, if you put meters per second, convert it and write the entire thing into electron volt, that you multiply this with 931, this will be mega electron volt. 931 mega electron volt, that will give you that energy, that will give you that energy involved in that process. Yes, remember, 1 AMU, 1 atomic mass unit is 1/12 the weight of C12 atom. Yes, it is approximately some 1.6 into 10 to the power minus 27 kg, right? Around that figure. Yeah. Cool. Okay. What else should we do to improve in the second attempt? Ayanshu, what you should do is, let's say we are doing modern physics today. After the class, practice more PYQs, but pre-COVID era, pre-COVID, okay, 2019 and before, those difficult PYQs. That is what you should practice. Next thing, let's say, sir, I think I forgot binding energy. I think I need more clarity. Just go through the textbook quickly. Sometimes people like reading, sometimes people like watching. You decide whether you want to watch or read. If you want to read, only read that part. If you want to watch, watch that part of my lecture, okay, either in the crash course or on YouTube. Anywhere, any old videos will also do, and see if you now get a better understanding of it. If sometimes maybe you have an understanding but you need more practice on that part, focus on that part. So I think this next 8 days, right, let's just focus on high weightage, and then the remaining 8 days, let's do all the other things. Obviously, simultaneously, every 4 5 days, try to give a mock test of full syllabus. Don't give up that habit of full syllabus mock test. So every Sunday, at least, bare minimum, for the next 1 week to 2 weeks, please give full syllabus mock test. Last week, let's just focus on full syllabus mock test. That's what you can do. Okay, cool. Yeah, great. Okay, yeah, semiconductor also will do in a bit. Yeah, yeah. Okay, great. So yeah, the crash course is there, guys. It is there right over here. I don't know how many of you have seen this link, which is there in the description box. It is there. Live crash course is there for all of you in English medium. Just see JEE Mains 2025 crash course English batch for the second attempt. It is not the first attempt. It is the second attempt special batch. It's just started. Okay, 12th March barely. So it's there for 999 rupees with the VIT Triple E and KCT, Karnataka Common Entrance Test. Please give it. It's the most important exam because Karnataka has a lot of colleges. VIT Triple E, obviously, you should give it as a backup exam. Yeah, that combination is also there. And Crash Pro is also there with the JEE PYQ book, which will be delivered to you. Okay, now since this is a little bit on the later side, I don't want you to buy this book right now because delivery might take 1 week, 2 weeks. You will lose out on that time. So don't go for this. Just go for this or this. Okay, PYQ books, anyways, you will have, unless you urgently want it, then fine. But otherwise, it's okay. All right. Moving on to the question. Assertion says the energy per nucleon is found to be practically independent of atomic number for nuclei whose mass numbers are between 30 and 170. Nuclear force is long range. In the light of the above statements, choose the correct thing. Okay, what do you think is the correct one? Come on, guys. All right, Ayanshu got me. Perfect. What do you think? The binding energy for the nuclear numbers between 30 and 170. Just I showed you one graph, right? See over here. I mean, like, look over here. Around this part to this part, it's almost in the same range. This whole thing from somewhere here to here. It's practically not changing only. Yeah, you can see that. That is definitely correct, obviously. Nuclear force is a long range force, and in the light of the above statement, choose the options below. Nuclear force is a long range force. Definitely wrong, guys. Nuclear force is a short range force. I just told you. The force will start becoming very weak within few femtometers. Femto is 10 to the power minus 15. Very, very small. It's an extremely short range force. It's the strongest force. So A is true, B is false. Yeah, that is correct. Very good. Option A. Very nice. Good, 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 good. Many of you got it. Excellent, guys. Moving on to the next one. The frequency of revolution of electron varies with n. I think the question printed is wrong. Options are correct. I think the question should have been the correct nuclear reaction is. Yeah, the correct nuclear reaction is. Which is the correct nuclear reaction? Which is the correct nuclear reaction? Which is the correct nuclear reaction? Okay. Neutron breaking down into proton plus electron and neutrino. Neutron breaking into proton, electron and antineutrino. Neutron breaking down into proton plus positron plus antineutrino. Neutron breaking down into proton plus electron plus neutrino. Very confusing. If you know it, or else you will be making a mistake. Tamil, no issues. Just carry on for now. And whatever you miss, please watch it recorded, okay, after some time. Guys, whenever there is a neutral particle, obviously it will break into one positive and one negative particle. One negative, the positive will be obviously proton, the negative will be electron. This is your beta, or I can say negative beta particle. This is obviously your proton, and this is your neutron. Simultaneously, I can also say if the reverse happens, if a proton, if a proton, if a proton has to convert itself into a nuclear particle, if a proton has to convert itself into a nuclear particle, okay, which is neutron, okay, so then imagine it emits something called as a positron. It emits something called as a positron. Balancing of charges should be there, and there must be some extra particle over here. This is a positive beta, you can say positive beta particle, or basically it is a positron. This is a positron. In each of these processes, there is something extra which comes over here. Yes, what you get over here is anti-neutrino, neutrino, and over here exactly opposite of that, which is nothing but neutrino. These are special particles which do not carry any mass or any charge. Yes, they are massless, they are chargeless. Yeah, these neutrinos and antineutrinos, there is no charge on them. There is no charge on them. There is no mass associated with them. They are new kind of particles. Yeah. Okay. So hence the answer for this will be option B. Keep this in mind. This nuclear reactions, please keep this in mind. Okay, very good. B. Many of you got that. Yeah. Now, you should also know about alpha decay and beta decay and gamma decay. This is not radioactivity. This is just the decay reaction which you should know. Any radioactive material which decays, undergoes any of these three phenomena. Alpha decay is nothing but doubly ionized helium nucleus. Doubly ionized helium nucleus. Okay. So that is one thing. That is one thing that you can get, alpha decay. The next thing that you can get is a beta decay, where an electron is emitted, a negative charge is emitted. So in that case, you will see the atomic number increases by 1. Atomic number increases by 1. What you will get, this is nothing but the daughter is an isotope. It's an isotope with the next periodic element, that is +1, Z +1, next periodic element. Yep, with the next periodic element, you will get an isotope. This is a different thing only. A-4, Z-2. It's a completely different daughter element. You will shift 2 places. Yeah, this daughter is basically -2 places in the periodic table. -2 places in that periodic table. Keep that in mind. Gamma decay, nothing happens over here. Keep that in mind. So if you have an element X with atomic mass number A, atomic number Z, then it will still remain A and this will be remaining Z, and you will get a gamma particle which is gamma decay. But put a star over here. This star represents that it was excited. It was excited and it has now come to a ground state. So this process involves gamma radiation. Okay, so this is what it is. All right. So moving on now to some semiconductor and logic gates related questions. Shall we do it? Yeah. Yes. Let's do some questions. PN junction. So first of all, remember you have two kinds of semiconductors, and in a semiconductor, first important property that you should know, semiconductor. The first important property that you should know, their conductivity is not too much, it is not too bad. There is something called as bands, conduction band and valence band. Valence band is completely full. Valence band is completely full. Conduction band, it is basically that particular energy levels where the electrons can transit, or basically it is partially full, where if the electrons are present, they participate in the conduction of electricity. That is why it is called conduction band. And there is a difference of energy between them. There is a difference of energy between them. This energy difference is very small. It is some few electron volts, because of which jumping of these electrons is easily possible. And that is why these electrons, when they jump over here, when these electrons they jump over here using thermal energy, they participate in the conduction of electricity, but that is not too much, it is decent. For insulators, the band gap is too much. For conductors, the band gap is negligible, or sometimes they might even overlap. So this band gap is few electron volts for semiconductors. Keep that in mind. Now, these kind of conductors are basically called pure or intrinsic semiconductors. Intrinsic semiconductors. They are very pure. They are not doped. They are not adulterated. But you obviously have other two kinds. One is a P type of semiconductor. In P type of semiconductor, the difference is that you have the conduction band, you have the valence band, of course. You have the conduction band, you have the valence band, of course. You create a new energy state of acceptor atoms. You create a new energy state due to the acceptor atoms, which basically are nothing but holes. Holes are like positive. So instead of the electrons jumping from here to here, now it is easier for them to jump from here to here. If you make it easy for them, this would be very difficult. This would be very difficult. So you create a new Fermi energy level of new energies which want those electrons, and that jump becomes easy. Acceptor electrons. These acceptor atoms are basically your trivalent atoms like aluminum, etc. Similarly, when you have n type, when you have n type, the difference is, when you have n type of semiconductor, the difference is, okay, this is your conduction band, this is your valence band, which is full. This is your valence band, this is your conduction band. You are going to create a new Fermi energy. This is made up of donor electrons, which is basically pentavalent atoms, and you create new Fermi energy, which is called then the n type of for electrons. This conduction band is now created over here. So instead of the electrons jumping from here to here, now these electrons will jump from here to here, which makes it easy. Otherwise, this jump was difficult. You are making the jump easy, thereby increasing the conductivity. So these kind of things, by the way, they are called as extrinsic semiconductors. They are called extrinsic semiconductors. Extrinsic semiconductors. Here you will see the concentration. Here you will see the concentration of electrons is much lesser than the concentration of holes. Here you will see the concentration of holes is much lesser than the concentration of electrons. Whereas in intrinsic kind of semiconductors, how many ever electrons are there will be equal to the number of holes, and that is also given a special name that is called as the intrinsic semiconductor concentration. How many electrons or holes are there per unit volume? That is called as the concentration of holes or electrons, also called as the intrinsic concentration of semiconductor devices. This Ni is also related to these both over here. In extrinsic semiconductor, if I dope it with holes or electrons, this Ni square will be nothing but Nh multiplied by Ne. So there is an equal to over here into. So Ni square is Nh into Ne is also an important formula which you should definitely know. Yep. Is that clear? Okay. Then when you join them together, P and N together, P and N type together, you get the PN junction diode. What you get is the electrons going from the N type to the P type and the holes going from the P type to N type. So this electrons which go from here to here and simultaneously the holes going from here to here, this particular process is called as, what is this particular process called as, guys? This particular process, yep, this particular process, this particular process which happens, it is called as diffusion. This is called as diffusion. And because electrons are going here, it's like positive charges going here. So the diffusion current, the current due to diffusion is set up from the P type to the N type. Because of those things, you will see this is becoming positively charged, this is becoming negatively charged. Yes, this becomes positively charged, N becomes positive because electrons are leaving them, holes are accumulating. The P type will become negatively charged. So there is a potential difference which is created. As you can see over here, this is negative charge, this is positive charge. So there is a potential difference which is created, which is called as the potential barrier. Yep. So because of the diffusion which happens, you will see there is a potential barrier which is created. Barrier means like a barricade. There is a wall, there is a some hurdle which is there. Now there is also a region of depletion which happens, meaning wherever the electrons move and transit, so you will see the electrons have left their places, the holes have left their places, it has been depleted, it has left. So there is a region of depletion which is formed over here, and even in that particular region you will see another type of transitions happen. It's exactly opposite to that. You will see electrons are pushed here, and you will see the holes will move here because of the electric field which is set up because of the barrier, high to low. So there is an electric field, obviously there is an electric field. Electric field will always go from higher to lower potential. So there is an electric field which goes from the N type to P type. This field will push the holes here and it will push the electrons on this side. So this contributes to a new thing in that barrier zone, which is then called as the drift current. This is called as drifting, and this current is called as the drift current. So the drift current will be exactly in this direction. So the drift current is exactly in this direction. When it is unbiased, then you will see that the drift current this way and the diffusion current this way, they are both equal in amounts. They are both going to be equal in amounts. But when you forward bias it, meaning the P is connected to positive, N is connected to negative, then you will see the diffusion current is more in the forward bias. Yes, the diffusion current. So you will see that the diffusion current is more. Drift current does not change much. It is still going to be the same. So the most of the current is because of the diffusion of that holes and the electrons. So that's how you will see a net current in this direction. That's how you will see a net current in this direction in forward bias. It will become conducting. When you do reverse bias, the depletion layer increases, the barrier increases, and that's when you will see that the diffusion current becomes very, very small and drift current doesn't change much. So it is still that very small value. So there is a very, very small, there is a very, very small net current. This is very, very negligible in nature. So that happens in reverse bias. So it becomes non-conducting. So that's why a diode is said to be, a PN junction is said to be a diode because it conducts in one direction and it blocks the current in the opposite direction. And if you draw the graphs of the voltage versus the current, it looks something like this. As you can notice over here, this is the forward bias. This is basically often called as the knee voltage. That is when you break the barrier. That is when you break the potential barrier and you are that barrier, that hurdle which was there, you overcome it. It is completely gone. And now suddenly the conduction increases, break the potential barrier. So you can see that the current is not directly proportional to the voltage. So it is not even going to follow Ohm's law. Yes. So in the forward bias, if somebody measures the resistance, it will be voltage by current. This will be not constant. So not following Ohm's law, non-ohmic, I can say. So it is non-ohmic device, non-ohmic device. You can also find delta R, which is delta V by delta I. This is called as dynamic resistance. Some questions can be there on that. Dynamic resistance, dynamic resistance. In the reverse bias, as you can see, my dear students, this is your reverse bias. This is your reverse bias because voltages are negative. What you get over here is a very small value of current that is called as the leakage. It feels like it is leaking. It is so small, but very high negative voltage will suddenly drop it, and there is something called as an avalanche. Avalanche is a sudden uh, breakdown of ice from snowy mountains. Suddenly, huge snow or ice breaks from those mountains and falls. So it's like an avalanche, avalanche, avalanche breakdown, avalanche breakdown. And when avalanche breakdown happens in the reverse bias, the voltage will remain constant. Yes, the voltage will remain constant, but the current can change. So this voltage, okay, is in the reverse bias, which will, yes, almost be a constant. This is useful in Zener diodes. It is useful in Zener diodes. Keep this in mind. You should know all the diodes, guys. First one, a diode like this with light coming out of it is light emitting diode. It is used in forward bias. The next one is exactly opposite of this. Where light is falling onto it. It is a photodiode, photodiode. So it is operated in reverse bias. And the last one, of course, is the Zener diode. The Zener diode, it looks like this. Okay, this is your Zener diode. It is also operated in the reverse bias. It is useful for voltage regulation. Voltage regulation. Keep that in mind. Yeah, it is useful for voltage regulation. Is that clear, everyone? Okay, let's see some questions. Okay, come on, my dear students, answer this now. Answer this. Hmm. Junction area of solar cell is made very narrow. No, in fact, it has to be made very big. It has to be made very big so that lot of solar energy falls and you are able to convert it into solar energy. So A is obviously wrong. Solar cells are not connected with external bias. Yes, solar cells, why do you need to bias it? Solar cells take the light energy, photons, convert it into electrons, kinetic energy, which convert their motion into current, and that's how voltage is set up. So this is definitely correct. There is no external bias. It is generator of electricity. It generates electricity. So why do you need external battery? It's like, do I need a battery for starting the generator? That will be stupid. Okay. LED is made of lightly doped PN junction. LEDs are made of lightly doped PN junction. No, it is heavily doped. Yeah, you need good doping so that when the uh, because of the high doping, when the electrons transit from N type to P type, they will enter the hole. You will see when the electron goes from higher energy to lower energy, photons are emitted. So you will get light. So if high doping is there, transition from higher energy to lower energy will emit more electrons, more photons. So obviously this is wrong. Increase of the forward current results in the continuous increase of LED uh, uh, light intensity. No, the intensity is not really dependent on dependent on your current. It is dependent on your doping also. So it is not entirely correct. This increase of the forward current and the doping is also very important, guys. The doping is also very important. So just not the current, guys. This is not wrong, correct exactly. Uh, Actually, yeah, you need more amount of doping for that to happen. LEDs have to be connected in forward bias for emitting of light. This is definitely correct. So B and E, I believe. Yes, so option B I think is correct. Just check it out. Yes, option B, correct. Very good. Many of you got it. Everybody clear about this? Shall we go ahead? Very good. Awesome. Moving on to the next question. What is the current to the battery in the circuit shown below, assuming the diodes are ideal? See, assuming if it is an ideal diode, there is no voltage difference. Delta V will be 0. So this just behaves like a normal wire, guys. So just think there is a normal wire and then solve the question. So current will come from here. It will go over here. It will get distributed here. And again, it will get accumulated over here. So these are two resistors in parallel. So because they are in parallel, the equivalent resistance, how much will it be? 20 and 20 will make it 10 ohms. Yes, it will become 10 ohms. So the current in that circuit will be voltage by the equivalent resistance. Voltage is 5, resistance is 10. So it will be 0.5 amperes. So 0.5 amperes is option D. Very straightforward. Diode was useless. At least one diode they could have put it in reverse bias, then it would be fun to solve. Very good. Awesome. All right. Let's go, guys. Let's go to the next question coming up on your screen. Which of the following circuits represents a forward bias diode? Which is forward bias? Forward means P should be at higher voltage, N should be at lower voltage. Yeah, come on, guys. P should be at higher voltage, N should be at lower voltage. Okay, multiple options may be correct, guys. Check this out. Over here, the N type is at lower voltage, -10, and the P type is at, this is P type is at lower voltage, and N type is at higher voltage. How can N be with high and P be with low? No, no, no. This is not correct, guys. This is going to be reverse bias. This is going to be reverse bias. Is that correct? So definitely A is not there. A is not going to be there. Everyone? Yeah. Which of the following circuits represents a forward bias diode? Correct. Then this is not there. That means wherever I see A, just eliminate it. Wherever I see A, eliminate it. Wherever I see eliminate it. I can see only one option, guys. C and E. Just check that out for now. See, this is P type. This is, let's say, your N type. Now, P is going to be at a higher volt, which is perfectly fine. And N, as you can see, 2 volts is at lower volt. Yes, definitely it is in forward bias. Definitely C is in forward bias. E, if you see, same thing will happen over here, guys. Your N type is 0 volt ground, and your P type, as you can see, is at a higher voltage. So definitely this is also going to be forward bias. So definitely E is also there. Everything else will be reverse bias. Everything else will be reverse bias. Is that okay, everyone? Yep. So directly you can mark A, this option number A. Okay. Moving on to the logic gates question. Moving on to the logic gates question. Why not B is forward bias? Hold on. B. Hmm. Why not B is forward bias? Actually speaking, yes, why not? So this is P. This is -10. -10 is more than negative 15. So actually, technically, this is higher potential. Oh, don't tell me the answer only is wrong over here. So this will be N type. -15 is at lower potential. Guys, this is also forward bias. I think the options given over here are wrong only then. Yeah, this is also forward bias. So even B is forward bias. What about D then? Is D also given wrong? This is -10. So this is P, which is at -10 means lower voltage. And this is N type. This is at high. -5 is more than -10. So definitely this is reverse bias. So I think it should have been E, B, and C. Yes, I think there is an option printing mistake. C, E, and B. Somebody pointed it out correctly. So B, C, and E, that will be the correct option. Yeah, not just C and E, B, C, and E. Yeah, thanks for pointing it out. Yeah, correct. Let's go, guys, to the next logic gates related things. OR gate, NOR gate, AND gate, NAND gate, XOR, XNOR, yep, NOT gate. All right, so let's have a look at these gates right now and some formulas also. Logic gates. Always remember you have two things in logic gates: input, output, and high, low, and all of that. So high, 1, true, plus 5 volts, or some plus V0 volts. All these mean the same thing, versus low, 0, false, false, or 0 volts. All these things mean the same thing. Any logic gate, any logic gate will have any particular logic gate will have certain inputs. It will have certain inputs and it will perform some operation and it will give you an output. What are those operations? Let's have a look at it. First is AND operation, say for example. So AND operation means the output is A dot B. So this is 0, this is 0, output is also 0. This is 0, this is 0. Sorry, this is 0, this is 1. The output is still 0. This is 1, this is 0. The output is still 0. Both are 1, then only it is true. Both are correct. And this and this. I want the assignment to be done, and I also want you to practice. I also want you to practice for dance. Both should be true. Then I will say that is, both are true, then the output is true. That is AND operation. Obviously, the AND gate looks like this. Obviously, the AND gate looks like this. The moment you make it NAND, the moment you make it NAND, that's it. You take this AND gate, put a dot in front of it. So instead of Y, the output will be then A dot B bar. So that's the only difference. So wherever you got 0, you will get 1. Wherever you got 0, you will get 1. Wherever you got 1, you will get 0. The negation of this, that's all. So that's the major difference in the output, nothing else. So the output will definitely be exactly opposite of this. The next gate that you should know is the OR gate. OR gate, yes, OR is that that is not exactly flat. It is like a semicircular thing. It's like an arc. Okay. And then you also have the NOR gate. It is not of OR. So you put the OR gate, put a dot in front of it. Yep. How will the inputs and the outputs look like? Well, Y is given as A plus B. Here, NOR means Y is A plus B whole bar. Y is A plus B whole bar. A0, B0, this is 0, this is 1, this is 1, this is 0, this is 1, this is 1. Output is high if any one is true. You can do the assignment or you can dance. So if you dance, correct. If you write the assignment, correct. If you do both, still correct. So this is 0, this is 1, this is 1, this is 1. So this is how the output will look like. The NOR means exactly opposite of this. So wherever you got 0, you will put 1. Wherever you got 1, you will put 0. So exactly opposite output. Then you also can write A dot B. You can also write A dot B. Mind this, A dot B whole bar for NAND gate as A bar plus B bar. This is very, very important. And A plus B whole bar, you can write it as A bar dot B bar. These conversions you should know. If there is a dot, becomes plus. If there is a plus, it becomes a dot. If the whole thing was a bar, then bars become separate. Then the bars become separate. This formula also you should know. Please remember NAND and NOR, they are called as universal gates. Yes, NAND gate and NOR gate, they are universal gates. The last gate is a NOT gate. Symbol is very, very simple. Yep. Y is whatever is the input, the bar of it. The bar of it. Yep. Diagram wise, you just put a triangle with a dot over here. So if this is 0, this is 1. If this is 1, this is 0. That's it. That's the simple form of that output that you get. That's all. It's just negating it. Okay. Keep this in mind. Certain important things which you should also remember. For example, 0 bar is 1. 1 bar is 0. 0 bar bar is 0. Basically, that is, if I put A bar bar, it is just A. It is just A. Keep this in mind. Okay, certain simple things which you should know. Yeah, this will help you in solving problems. So that is about logic gates. Let's solve some questions. The truth table for the following circuit is. The truth table for the following circuit is. Okay. Ramurthy, definitely you will get the session PDF. I mean, just see right here, the last lecture, if you have seen, where did it go? Live, go to live. Yeah, yesterday we did know this particular ray optics session. I don't know whether you saw this. After the session is over, the PDF will be generated. Okay, it takes some time. Give it, today's holy holiday. So I don't think many people are there in the office. So maybe by tomorrow, this PDF will come for today's session. Okay, we'll try. I don't know. I'll see if I can get someone to make the PDF. Anyways, coming back to this particular question, what do you think is the correct answer? The truth tables. Try out few things. Try to eliminate. See, try to eliminate the options. That will be better. Yeah, try to eliminate the options. Try to eliminate the options. Do you notice if you take 0, 0, everywhere the output is 0, so that can't be used for elimination. Second, 1, 1, 1, 0, maybe. Third one, 0, 1, 0, 1. I think better to use this option to eliminate 1, 1, 0 or 0, 1, one of them. Okay, so, oh, that also they have made a mistake here. 1, 1, 1, 0, 1, 0, 1, 1. Okay, let me try with 1, 1. 1, 1. Okay, both are 1. Let's see what will happen. The truth table is little bit messed up, guys. I mean, like, if this is 1, this is 1, this is also 1. B will become B bar, that will be 0. This is 1, so this will become 0. This will become 1. 1 and 0, 0. 0 and 1, 0. 0 or 0 is 0. So 1 and 1 should give you 0. 1 and 1 should give you 0. I think this is seen over here. This is seen over here. This is also seen over here. 1 and 1 is not giving 0. So A option is eliminated. So 0, 0, no, I will try 1, 0 now. I'll try 1 0 now. If this is 1 and this is 0, then this will be also 1. This will become 0. This is 0, so this will become 1. This 0 will go as it is. 1 and 1 is 1. 0 and 0 is 0. 1 or 0 is 1. So 1 0 should be 1. 1 0 should be 1. 1 0 is 0, gone. 1 0 should be 1. So either it is B or it is a D. Now try the last one then. Now try the last one. Anything you can do. 0 1 will try. 0 1 will try. So if this is 0, if this is 1, so this 0 will go over here. B is 1, so B bar will be 0. A will become A bar, so 0 will become 1. B is 1, so it will remain 1. 0 and 0 will remain 0. 1 and 1 will become 1. 0 or 1 will become 1. Yeah, so it should become 1. 0 1 should become 1. That is this option. 0 1 is becoming 0. So B option is eliminated. So hence the correct answer is D. Got it? Very good. So that's how you eliminate. Don't start with 0 0, guys. That will be unnecessarily waste. All right, so let's move. Another question. I think this one you can solve it on your own, guys. Now, come on. This one also you can solve on your own. Come on. There is a NAND gate, there is a NOR gate, and again there is a NAND gate. Crazy. So how are you going to figure out which kind of gate it is? What is XOR gate? XOR gate means basically both should be opposite. Wait, let me show you over here. XOR means both should be opposite, then only it is true. OR gate with that double curve, that is XOR gate, meaning if this is 0, this is 0, this is 1, this is 1, this is 0, this is 1, this is 0. Sorry, 1. If both are opposite, only then it is true. If both are similar, then it is 0. So that is how the output should look like. That is called as a XOR gate. XNOR means the opposite of this. So XNOR means like this, like this, like this, like this, like this with a dot. So the output is exactly opposite. Both are same, then it is true. Both are false. Sorry, both are opposite, then it is false. So that will be the output. Is that okay? Cool. Gate. The symbol for that, for XOR, it is Y is equal to A plus with a circle and B. For XNOR, it is Y is equal to A, circle with that plus and then put a bar over there. So that's the symbol for that. Cool? Okay. Let's go, guys. Let's go. What kind of gate is this? Figure this out. Just draw the truth table, guys. You will get it. Just draw the truth table. Yep. Oh. Yeah. What is this? What is this? This is A, this is B. This is A dot B bar. This is A, this is B. This is A plus B bar. And then there is again a dot over here with basically AND operation. So this is A dot B bar dot with A plus B whole bar, and then the bar of it because there is a NOT gate over there. So that is exactly what is happening. That is exactly what is happening. We'll do the NOT operation later on. But what do you think the truth table will be? Just try it out, guys. Just try it out. A and B, you can put it over here. A is 0, B is 0. This is 0, this is 1. This is 1, this is 0. 0. This is, let me give some space. 0, 0, 0, 1, 1, 0, 1, 1. Yeah. A dot B. A dot B, guys, and operation. So this will be 0, 0, 0, 1. But you have to take the bar of it. So the bar of it means this will be basically 1, this will be 1, this will be 1, this will be 0. Okay, perfect. A plus B, this is OR gate. So this will be 0, 1, 1, 1. But the NOT of it, so this will be nothing but 1. This will be 0, this will be 0, this will be 0. Now take these numbers. Yes, just concentrate your attention only on these numbers here. and these numbers over here. Okay, so you have to take the dot of it. Dot of it means and 1 and 1. 1 and 1 is 1. 1 and 0, 0. 1 and 0, 0. 0 and 0, 0. So that is this operation. But if you take the bar of this, now you take the not operation. Now you take the not operation. 1 will become 0, 0 will become 1, 0 will become 1, 0 will become 1. What kind of gate is this? What kind of gate is this? Yes, this is a OR gate. This is basically, yep, OR gate operation. This is nothing but your OR gate operation, which is D option. Perfect. Understood how to solve this kind of questions? Yeah. Very good. Excellent. Excellent. Very nice. Moving on to the next question. Which of the following circuits has the same output as the given circuit? Guys, whatever output is there here should be the same. Basically, they are asking which gate is this? Which gate is this? As you can see, the first option is when you short the two terminals of a NAND gate, actually speaking, the A option is a NOT gate. This option is a AND gate. This option, I don't know why is the same. Yeah, can you see it is exactly the same? So again, this is a NOT gate only, unless I missed something. This is also a NOT gate only. So they're asking whether it is a NOT gate or whether it is an AND gate. Whether it's a NOT gate or whether it is an AND gate. Please remember whenever, yeah, the two terminals are shorted of a gate, then it becomes a NOT gate. Yeah, when the two terminals are connected by a wire, it becomes a NOT gate. So I think maybe this was OR gate. Maybe they would have messed up something or whatever. Anyways, so what will this be, guys? That is the question. So this is A, so this is A, this is B, so this is B bar. This is also A, this is also B. And then you have to again try out all the truth tables. This will be nothing but A dot B. This will be, sorry, A dot B bar. This is nothing but A dot B. And then this is OR gate with a NOT gate. So A dot B bar is there. And you have A dot B over here. And then OR gate is there. And then you have to take the NOT operation. So try it out and see what do you get. Okay. So try this. Oh, sorry. By mistake, I put NOT gate. My bad. Sorry. Yeah, this was a NAND gate. My bad. This AND is not shorted. This is a NAND gate. My bad. This is a NAND gate. Yeah. Thank you for pointing it out. I think C option, there was this dot which was missing. I think that is a misprint, because how can two options be same? I think this is a misprint over here. Yeah, I think it should have been just this. I think this should have been just this. So in that case, it is just an AND gate which is shorted. It is just an AND gate which is shorted. Yeah. If you give 0, 0, 0 will give you 0. If you give 1, it will be 1. That's it. It will be the same output. So Y will be just equal to B. What is it? It is a useless gate. Whatever input you give, it will be the output. So I think these were the options. So try it out as homework, guys. Yes, I want everybody to try this out as homework and put up the answer in the comment section. Okay, I have given you this much hint. So let's do one last question maybe. Yeah, one last question. Here it is. To obtain the given truth table, the logic gate placed at G should be. The logic gate at G should be. Yes, try this particular question also, my dear students, as homework. It's not very difficult. What should be here so that you get this particular output? Hint I will give you over here. This is A, this is B bar. This is B bar, this is basically A. But this question, I think when it came in JEE mains, this was a bonus question because you do not get this particular output over here. So I think this, actually do not take it as homework. I remember this question came in the JEE mains. This came out as your bonus question because none of the gates were matching and stuff like that. Yeah. Sir, input is different in A and C. Which one? Oh, this was A and this was B. Oh, my bad. Yes. So then no point of saying that these both are same. Yeah, this is A, this is B. Okay, my bad, guys. So then this will be just a NOT gate. This will be just a NOT gate. So here Y will be A bar. Here Y will be then B bar. Y will be B bar. Yes, correct. Y will be B bar. Okay, that last question, don't take it as homework. That was a bonus question because none of the options were matching. So just take one question as homework, guys. Yeah, and try to solve that. Cool. Yes, perfect. Thank you, Harish, for pointing that out. The inputs were same. Yeah, sometimes it happens. Yeah, this was bonus. Ignore that. And yep, that brings us to the end of the class. So I hope you enjoyed it. We did all the concepts from modern physics, semiconductor, logic gates, and it was a very good revision for all of you. Practice these questions. PDF, I will share it very soon. And next class we'll be meeting. I think we'll be taking up, if I'm not wrong, electrostatics, gravity, Gauss law, all those things. High weightage. Many questions came from these three topics, so we'll be doing that. Okay, on Monday. So tomorrow, I think you have chemistry and mathematics. Yeah, that's the class. Today evening also you have a class, and Monday I'll be meeting you again. Okay, same time. Bye bye. Take care. Have a great time. Thank you for liking. If you're not yet liked, please like it. Not yet subscribed? I mean, really, please subscribe. And yes, put up the answers in the comment section. Have a great, great Holi and wish you all a very, very happy and I really happy Holi. And I really hope that, just like Holi is a festival of colors, your life also be very, very colorful, not just for today, but forever. Okay. And that can only happen when you study very well for the next couple of days. So I hope you celebrate the next Holi in IIT or NIT or BITS or some great government or some nice private college, and you have a lot of fun with a lot of your friends. You will have a new set of friends. All these years you had school friends throughout your journey. Now it's the time you make new friends. So I really hope you have a wonderful, colorful Holi, not just this time, but maybe even next time. All depends on what you do for the next few days. Bye bye. Have a great time. Take care.